Next up in our list of basic skills necessary for college algebra, we have operations with complex numbers. In this video, we'll review addition and subtraction, multiplication, and division with complex numbers. Let's get started with addition and subtraction. To add or subtract complex numbers, the procedure is simple. Combine the real parts and combine the imaginary parts. This is going to feel just like combining like terms. Remember to always express your complex numbers in the standard form a plus bi. That is, keep the real part separate from the imaginary part. Let's look at example 4a. We have the complex number negative 3 minus I plus the complex number 4 plus 2/3 I. As we saw with adding polynomials together, if there's a plus in between your terms, the parentheses aren't making much difference. So I'm going to go ahead and drop those on my first step here. We have negative 3 minus I plus 4 plus 2/3 I. Now I want to combine the real parts. So I'm going to take negative 3 plus 4. That gives me real number 1. And then we want to add negative I to 2/3 I. Now, the coefficient on that I right there is understood to be a 1. So for a minute, I'm going to ignore the I, and I'm going to combine the coefficients. We have negative 1 plus 2/3. Let's think of negative 1 as negative 3 over 3, so that we have a common denominator making it compatible with 2/3. Negative 3/3 plus 2/3 gives me negative 1/3. So when we add negative 1 and 2/3 together, we get negative 1/3. But don't forget, we also had an I in that term. So our final answer is 1 minus 1/3 I. The real part is 1. The imaginary part is negative 1/3 I. Let's try the next one. We have the purely imaginary number 4i minus the complex number 5 plus 2i. Because that complex number is preceded by a negative, to break up the parentheses, we'll need to apply the distributive property. So we have 4i minus 5 minus 2i. Now remember, in standard form, the real part comes first. So I'm going to begin my answer with the real part, which is negative 5. Then we'll combine imaginary parts, 4i minus 2i. 4 minus 2 gives us plus 2i. So our resulting complex number is negative 5 plus 2i. If you're comfortable combining like terms with a polynomial, that's going to be a pretty easy skill. Let's talk about multiplication. With multiplication, we'll use the distributive property and FOIL where necessary, but the one thing you have to watch out for is the I squared. If that pops up, remember to replace the I squared with the value negative 1. Example 5, we're going to simplify and express the answer in the standard form a plus bi. That is real part first, imaginary part second. On example 5a, we have the product 7 minus 5i, cut again, 3, 2, 1. We have the product of the complex number 7 minus 5i times the complex number 2 plus 3i. We can treat this as if it's the product of two binomials and simply FOIL it out. So multiplying our first two terms, we get 14. The product of our outside terms, 7 times 3i is 21i. The product of our inside terms is negative 10i. And the product of our last terms is minus 15i squared. Now, as is usually the case, we have two matching middle terms that we need to combine. But also notice we have the I squared here on the end. We're going to need to replace that with a negative 1. So on the next step, we end up with 14 plus, combining our middle terms, we have 11i, and then we have minus 15 times negative 1. Let's call that minus 15 times negative 1 a plus 15. Then combining our real parts, we end up with 29 plus 11i. Did you know that you can check this with your calculator? Might be a good skill to know, so let's check it out. I'm going to type in the original problem, 7 minus 5i. Remember, second decimal picks up the I on your calculator, times 2 plus 3i. The calculator does the FOIL and reports the answer in standard form, 29 plus 11i. That's good to know, right? Let's try our next example. We have the purely imaginary number negative 4i times the complex number negative 5 minus 8i. To simplify, we're going to use our distributive property. Negative 4i times negative 5 gives us 20i, and negative 4i times negative 8i gives us plus 32i squared. There's that I squared again. Remember, we replaced that with negative 1. So we have 20i minus 32. That's pretty good, but it's technically not in the right form. Remember, in standard form, the real part must precede the imaginary part. So I'm just going to transpose these two terms, keeping their signs, negative 32 plus 20i. And remember, you can certainly check that with your calculator. Let's try our next example. We have the complex number 8 plus 3i squared. Now be very careful here that you do not distribute that exponent. Instead, we want to think about it as 8 plus 3i times 8 plus 3i, which is a simple case of FOIL. So we have first terms 8 times 8 to give us a product of 64. The outside terms have a product of 24i. Inside terms, product of 24i. And last, 3i times 3i gives us 9i squared. Let's combine our matching middle terms and replace the I squared with negative 1. We have 64 plus 48i plus 9 times negative 1. Now, as you get used to working with that I squared, a shortcut is to realize when you have the presence of an I squared, it simply changes this sign, right? Plus 9i squared became minus 9. So if you want to skip that step, if you feel comfortable with that, that would be fine. 64 minus 9 gives us 55 plus 48i. Let's double check that one with the calculator. So our original problem was 8 plus 3i quantity squared, and we have 55 plus 48i. We did a good job. Okay, the last operation that we want to examine with complex numbers is division. Now, dividing complex numbers doesn't really feel like division. To divide complex numbers, we're actually going to rationalize the denominator. Remember, I represents the square root of negative 1. So if I have an I in the denominator, technically I have a radical in the denominator. So we're going to simplify using the complex conjugate. Remember, the conjugate of a plus b is a minus b. If I have a complex number in there, we simply call it a complex conjugate. So in example 6, we want to simplify and express the answer in the form a plus bi. We have the fraction negative 2 over I. Now, technically, I can be written in standard form as 0 plus I. The real part is 0, the imaginary part is I. The complex conjugate then would be 0 minus I. So to rationalize the denominator here, I'm going to multiply the top and the bottom by negative I. Multiplying straight across the numerators, negative 2 times negative I gives me positive 2I, and I times I gives me negative I squared. Now, look what happens to the radical in the denominator. The I squared gets replaced with negative 1. So I've got the negative coefficient, and I'm replacing I squared with negative 1. So we have 2I over the rational number 1, which we could also just call 2I. Let's double check that one with the calculator for good measure. Negative 2 divided by I, or you could type it in as a fraction, gives us 2I. Awesome. Let's try one with two terms in the denominator. We have 5 divided by 3 minus 2I. So I'm going to multiply the top and the bottom by 3 plus 2I. Now, when we get multiple terms, it's helpful to insert some parentheses to keep all your binomial terms together. Okay, in the top, I'm just going to glue the numbers together. 5 times 3 plus 2i. You may be tempted to distribute that 5 there, but hold off on distributing it. It may be the case that it will reduce with some factor in the denominator later. In the denominator, however, I do want to execute the FOIL. So we're multiplying conjugates. The first two have a product of 9. Remember, when you're multiplying conjugates, your outside and inside terms always cancel. So we'd have plus 6i minus 6i. That would go away. And our last terms would be minus 4i squared. Okay, let's apply our shortcut in that denominator. Remember, the I squared is a negative 1, so ultimately it's going to change that sign. And we end up with 9 plus 4. So we have 5 times 3 plus 2i over 13. Now it's reduced, but it's not in that standard form a plus bi, so we have a little bit more work to do. So at this point, since there's no common factors between 5 and the denominator 13, I am going to go ahead and distribute and call it 15 plus 10i over 13. Now remember, I have to keep the real part separate from the imaginary part, so I'm going to take each term in the numerator and place it over the denominator. So we have 15 over 13 plus 10i over 13. Or you could write that 10/13 times I if you wanted to. Okay, that one's definitely worth checking. So let's type in our original fraction. 5 divided by 3 minus 2i. The calculator gives us 15 over 13 plus 10 over 13i, equivalent to what we came up with. Awesome. One more problem. We have complex number 5 minus I over complex number 7 plus 3i. So I'm going to multiply the top and the bottom by the conjugate of the bottom. As usual, let's insert parentheses to keep everything organized. And this one is a little bit of a different case because in the numerator, we've got the product of two complex numbers. So let's go ahead and execute the FOIL there. The product of our first two terms is 35. The outside terms give us a product of minus 15i. Inside, we have minus 7i. And last, plus 3i squared. In the bottom, we're multiplying conjugates. So we're going to end up with the product of the first two terms, 49, times the product of the last two terms minus 9i squared. Remember, the outside and inside terms cancel there. Okay, simplifying. We're going to combine middle terms in the numerator, and the I squared is going to change this sign. That gives us 35 minus 22i minus 3. In the denominator, remember the I squared gets replaced with a negative 1, which is going to change this sign to 49 plus 9. Continuing to simplify the numerator, we're going to combine our real parts. 35 minus 3 gives me 32 minus 22i. And in the denominator, 49 plus 9 gives us 58. Okay, that's pretty good, but remember, we always have to express it in standard form. So we need to keep the real part separate from the imaginary part. As we did on the previous example, we'll split this into two fractions. Each term in the numerator gets placed over that denominator. And then we can reduce. The common factor between 32 and 58 is 4. 32, actually, I think it's just 2, right? 32 divided by 2 is 16, and 58 divided by 2 is 29. The common factor between 22 and 58 is also 2. 22 divided by 2 is 11, and 58 divided by 2 is 29. So we end up with our final answer. I'll sneak it in over here. 16 over 29. Not enough room. Let me scoot down here. 16 over 29 minus 11 over 29. And you can put the I in the numerator or on the side. Okay, we should probably check that one with our calculator to be absolutely sure. Plus, it's pretty easy to check with our calculator. So we'll type in the original problem, before we made any changes. And in the denominator there, we had 7 plus 3i. And we have 16 over 29 minus 11 over 29i. So adding, subtracting, multiplying complex numbers feels a lot like working with polynomials, but when you're dividing complex numbers, it really just feels like rationalizing the denominator.